Today we're going to be talking about graphing quadratic functions. And I do this a little bit differently than the book does it, just in terms of the process that I particularly want. Okay, so a quadratic function. You have that parent function. So it's a y equals x squared, f of x equals x squared. And this is standard form of a quadratic. There's also a vertex form that sometimes we study in Algebra 1. The type of graph is called a parabola. How we get the axis of symmetry is negative b, so opposite of that value, over 2a. And that axis of symmetry is a line. If I were able to fold this parabola over this line, this point right here also is that point right there. I have a point here, and then if that axis of symmetry thing wasn't in the way, there's a point right there. So they're points that are symmetric. Every point that you find that's, say, 2 units over here from the axis of symmetry, there's going to be a point that's 2 units over there. One key point on that is the vertex. And how we get the vertex is, notice how the axis of symmetry goes straight through the vertex. And I'm kind of surprised they don't have that on here. The vertex is, we have a vertical line, so that's an x equals line, so we do negative b over 2a to get the x value, or the x coordinate of the vertex. And then to get any y value, you just evaluate. Okay, so we would plug in whatever we get here for this x in here for x to get yourself out a y. And the y-intercept is c. How I remember that is y-intercept, you make x equal to 0, if x equals 0, that term goes away, that term goes away, all you're left with is c. So let's do an example of this. And the book does this a little bit differently. They say use the table of values to sketch that function. They just randomly want you to pick points. And I think that that's going to be challenging because some people aren't going to pick the right points and you're not going to get a good graph. It's not going to make sense. So I want us to use this x equals negative b over 2a to get the x coordinate of our vertex. And we're going to put that in here as our middle point. So I'm just going to put a v there to denote that that's eventually going to be our vertex. So opposite of b. So b is negative 4. The opposite of that is 4 over 2 times 1. So I have 4 over 2, which is a 2. So my x coordinate is 2. To get your y coordinate, plug in. So I have 2 squared minus 4 times 2 minus 2. So a 4 minus an 8 minus a 2, that works out to be a negative 6. So I have the point 2, negative 6. That's my vertex. Now pick numbers greater than 2 and numbers less than 2. I'm going to pick 3 and 4 for numbers greater. I'm going to pick 1 and 0 for numbers that are less. And then get your y values out. So plug in 0 for x. You get a negative 2. When I plug in 1, I get a negative 5. When I plug in 3, I get a negative 5. When I plug in 4, I get a negative 2. Hopefully you notice there's a fun pattern there. Because our graph is symmetric, if you go over 1x less and 1x more, you're going to have the same points. And then 0 was negative 2. And then I am at there. And that gives you your graph. Again, the book has you pick random points. I want you to start with this vertex. Find the vertex. Put that in the middle of your chart. Pick numbers 2x coordinates less, 2x coordinates more. Let's talk about the domain and range. This is a polynomial. Any polynomial's domain is all real numbers. The range. And I struggled with range when I was a student. I remember specifically struggling with range when I was a student. I always had to look at the graph. So I look at my graph and I say, okay, this is my lowest y value here at -6, and my parabola is opening up. So y is greater than or equal to -6. Okay, next. State the vertex equation of the axis of symmetry and y-intercept. So now just looking at this graph. Remember that vertex point is that lowest point or the highest point. So here, that point right there is the vertex. So that vertex is 2, -2. Our axis of symmetry is a line, x equals 2. The y-intercept is where your graph hits the y-axis. So our y-intercept in this case is 2. And it just works out. In this lesson, I have a lot of 2's and -2's. It's just because a lot of the numbers I picked, it's not always going to be that way. For this B, notice how now your vertex is a maximum because your graph opens down. So my vertex is 2, 4. Axis of symmetry, again, is a line. X equals 2. And the y-intercept is -4. If you want to put the y-intercept as coordinates, I personally prefer that. Just because so that you understand that it's a point. It's a point on your graph. Okay, find the vertex, equation of the axis of symmetry, and y-intercept. Okay, remember for our vertex. To get the x coordinate, it's -b over 2a. Actually, if you find the axis of symmetry first, they end up being the same thing. So opposite of b. Opposite of b is opposite of -8, which is a +8, over 2 times by a -2. So I have an 8 over a -4, and that ends up being a -2. So the x coordinate of my vertex is -2. But I've just found the axis of symmetry. I abbreviate that AOS. X equals -2. So now all I have to do is I have to plug in this -2 here for the x's to get my y coordinate of my vertex. So -2 times by -2 squared minus 8 times by -2 minus a 2. So I have here 4. -2 squared is 4 times by a -2 is a -8 plus a 16 minus a 2. And we get 6 for the vertex. Okay, so our vertex is -2, 6. The axis of symmetry. We find that when we find the x-coordinate of the vertex. Now the y-intercept. And if I was in the classroom, I would actually physically be doing this. I'd put my thumb over that term and that term. Because if I make x equal to 0, those terms go away. My y-intercept is -2. Again, I personally prefer you writing it as coordinates so that you understand that it's a point. Okay, let's do another example of this. So our vertex. Axis of symmetry, and then I'll do y-intercept over here. Quite honestly, y-intercept's the easiest thing to find. 0, if I make x 0, that goes to 0, that goes to 0, -2. Done. Okay, I think y-intercept's the easiest thing to find. Axis of symmetry is the next easiest thing to find. So the axis of symmetry, remember, is a line. X equals -b over 2a. Remember, this coefficient is a, b, and c. Simplifying that out, we get a -1. So my axis of symmetry is -1. The vertex, the x-coordinate of the vertex is what your axis of symmetry is. So now all I have to do is plug in and I simplify that out and I get a 3 minus a 6, I almost said plus 2, minus 2, and that ends up being negative 5. So now I've found my vertex, axis of symmetry. Again, remember that's a line. I want that written as a line. And my y-intercept. Maximum and minimum values. So parabolas, based on how they open, have a maximum or a minimum. If A is positive, your vertex is a minimum. If A is negative, your vertex is a maximum. How I remember this is if you are a positive person, you smile. If you are a negative person, you frown. Okay, and then I literally just look at where my vertex is. And I have something that I do with my fingers that I can show you during class to help myself remember. Okay, so consider that function, determine whether the function has a maximum or minimum value, find that value, state the domain and range. Okay, so let's look at our equation here. This equation here, A is negative 1. So if you are a negative person, you frown. Vertex is a max. Okay, finding the value. This is key, and this is something I didn't realize until I started teaching calculus a few years ago. That is the y value. Okay, so I have to find the x value, plug in, then get the y value. So I get the x value of my vertex. Okay, it's the y value of the vertex. I should put that in there. To get the x value, again, you do negative b over 2a, and you get a negative 1. Plug that back in now. So the max value is a negative 1. I know they worked out to be the same number. I'm not happy with the example I picked, but I'm going to move on. Domain and range. Like I said, domain, since this is a polynomial, all real numbers. The range. It is the maximum. It is the maximum value. It is the highest value. So y has to be less than or equal to negative 1. Because we've just said this is the maximum, the highest, the biggest it can be. Okay, graphing quadratic functions. And honestly, we've already done this. I did this in the first example, but this actually simplifies this a little bit. I do this with my Algebra 2 students. Okay, and this actually is just a lot easier of a way. And this is all I expect you to be able to do. I do the table of values because that's a typical way that a lot of students graph things, or when you first start graphing something. But this is all I want you to do. Find the equation of the axis of symmetry. Okay, you find the vertex, and you determine whether it's a maximum or minimum. You put the y-intercept, and then use symmetry to find additional points. So use symmetry to graph your symmetry point with your y-intercept, and then graph the points. So let me show you what I mean by this with an example, kind of making this a little bit easier than the first example we did. Okay, so I get the axis of symmetry by doing negative b over 2a, and that simplifies to be a 2. So my axis of symmetry, x equals 2. That's the y-coordinate of the vertex. Now I plug in. So here I have 4, negative 8, plus 16 minus 5. Just want to make sure my answer is right here. Yes. 3. Okay, so now that I have my vertex, I plot that point. 1, 2, 1, 2, 3. Okay, so there's my vertex. This guy, since A is negative, opens down. Find your y-intercept. Okay, my y-intercept is always, always, always going to be that number. So my y-intercept, 0, negative 5. Okay, so 0, negative 5. 1, 2, 3, 4, 5. I'm going to draw in the axis of symmetry. I never have my students draw it in. But I want to show you here with this axis of symmetry that here I'm 2 units away. So go 2 units the other direction to get you another point, and then sketch in your curve as best you can. Make sure it has some curve to it. Mine looks kind of straight, but that's just because of what I'm using to record this video. Your domain, all real numbers. The range, okay, y, this was a maximum less than or equal to positive 3. Okay, so that is our graphing quadratics. Thank you for watching.